Welcome to another example of time value of money. In this example, we'll look at the case of present value of an ordinary annuity. And we'll see how to find out the present value of an ordinary annuity using multiple methods. So the question at hand is, how much would you be willing to pay today for an investment that would return rupees 800 each year at the end of each of the next 6 years? Assume an interest rate of 5%. So let us understand this example using the time scale. So the tenure given to us is 6 years, 0, 1, 2, 3, 4, 5 and 6. Now we want to make an investment today, which is at the beginning of the time scale. So this investment, let's say, is the present value, and we want to find out how much that is. And this investment should return rupees 800 each year at the end of the year. So that means at the end of first year, we should be getting 800 rupees. At the end of second year, again, we should be getting 800 rupees. At the end of third year, 800, fourth 800, fifth 800, and sixth also 800 rupees. The rate of interest is assumed to be 5% each year. So this is a case of an ordinary annuity where we are getting paid 800 rupees at the end of each of the next 6 years. And now we want to find out the present value of this ordinary annuity. So let us look at the first method of solving this problem, which is to use the formula for compounding or discounting. So let us look at this time scale again. Now this present value, which is a lump sum amount, can be broken down into multiple present values such that this first amount, let's say this is PV1, this gets converted to 800 rupees in 1 year at 5% interest. The second component, let's say this is PV2, gets converted into 800 rupees in 2 years at an interest rate of 5% per year. Similarly, PV3 will get us 800 rupees at the end of 3 years at 5% interest per annum. So when we add all these present values, that is P1, PV2, PV3 and so on up to PV6, we will get the total present value that will give us 800 rupees at the end of each of the next 6 years at 5% interest rate. So in other terms, the total present value is equal to PV1 plus PV2 plus PV3 plus PV4 plus PV5 plus PV6. So how do we find the value of PV? So that we can easily use the same formula for finding out the values of PV1, PV2 and so on up to PV6. Now if we take the case of each of these PV1, PV2, PV3 and so on, you will find that it is a case of finding the present value of a single cash flow, or in other terms, it is basically compound interest. Now the formula for compound interest is the final amount is equal to the amount deposited, that is the principal, into 1 plus rate of interest divided by 100 to the power n, which is nothing but the number of compounding periods. Now A is the amount received at the end of the tenure, so we can say this is the future value. P is the amount which is being deposited at the beginning of the tenure, so this is the present value, into bracket 1 plus R by 100 to the power n. Now we can also consider this R by 100 as I. So future value is equal to present value into 1 plus I to the power n. Or since we have to find out the present value, PV is equal to future value divided by 1 plus I to the power n. Now let's try to write this formula for PV1. So PV1 is future value 1, which is at the end of the first year, which is 800 rupees, divided by 1 plus I. So 1 plus, now I is 5 divided by 100, which is 0.05, to the power n, which in case of PV1 is only 1, plus, let's take PV2. Now the future value for PV2 is also 800 rupees, because at the end of 2 years the amount received is 800, divided by 1 plus 0.05 to the power 2, because it is 2 years, so on, plus for PV6 it will be 800 divided by 1 plus 0.05 to the power 6. Now let me pull my calculator here. So 800 divided by 1.05, so 800 divided by 1.05, so this comes out to 761.9. So 761.9 plus, now we'll first take the denominator, so 1.05 square and 1 by x multiplied by 800, so this is equal to 725.62. So similarly, let me calculate the remaining values and note it down here. So after calculating all these values and summing them up, the total comes out to be 4060.54 rupees. Now in this example, we have the tenure as 6 years. So we calculated the present value for each of these 6 years separately. Let's say the tenure was like 20, 30, 40 years. Then the calculations will become very tedious. So let's look at the second method, which makes this calculation much easier. So in the second method, we will use the formula for the present value of an ordinary annuity. Now in one of the previous videos, we have seen how to derive the formula for finding out the present value of an ordinary annuity. So the formula is PV is equal to A, where A is the annuity amount, into 1 by I minus 1 divided by I into 1 plus I to the power n. So let's plug in these values. So this is what we get. Now let's further simplify it. So 800 into 1 divided by 0.05 minus 1 divided by 0.05 into, this becomes 1.05 to the power 6. So let me pull my calculator. So let's first find out the value of this portion. So 1.05 to the power 6, so 1.05 x to the power y 6 multiplied by 0.05, and this is 1 by x, and this has a negative sign, so, and then plus 0.05 reciprocal. So 0.05 1 by x. So this is equal to 5.0756 and multiply this by 800. So we get 4060.55. So this is equal to 4060.55 rupees. Now this is pretty much the same answer that we got in method 1, just that in method 2 we have to remember this formula. Now let's move on to the third method. So the third method is to use the present value factor of an ordinary annuity, also known as PVFA. Now in the second method, we had used this formula for finding out the present value of an ordinary annuity. Now let's break this formula into two parts. So let's say this is part 1 and this is part 2. Now part 2 has variables like I and N, so rate of interest and the tenure. Now rate of interest and tenure generally take the values of 1, 2, 3, 4, 5 and so on. So if a table can be created with the value of this portion for the combinations of values of N and I, where N can be 1, 2, 3, 4, 5. Similarly, I can also be 1, 2, 3, 4, 5. Then we simply have to refer to the table to find out the value of this portion for the values of I and N given to us, and then we have to multiply that value with A. So this formula can also be written as A into PVFA. Now let's look at this table to find the value of present value factor of an annuity for our case. In our case, N is 6 and I is 5. So on the screen, the table for present value factors of an annuity of rupee 1 is shown. I mean, it can be rupee 1, $1 and so on. So anything which is a unit of a currency. Now why is it called the present value factor of an annuity of rupee 1? So if you recall, the formula was present value is equal to A into present value factor of an annuity. Now A, if considered 1, then basically the factor represents the present value of an annuity of rupee 1. So basically somebody has taken the second part of the formula and calculated the value for different periods, that is 1, 2, 3, 4, 5, 6 and so on, and different interest rates, 1%, 2%, 3% and so on. Now in our case, N, which is the number of periods, is 6, while the rate of interest, which is I, is 5%. So the intersection of these two gives us the value 5.0757. So what this means is that if you want an annuity of rupee 1 for the next 6 years, at the end of each year, at an interest rate of 5%, then you need to invest rupees 5.0757 today. So let's now plug in this value in our formula to find out the present value in our case, where the annuity amount is 800 rupees. So let us plug in the values that we found. So A is 800 and PVFA is 5.0757. So let's calculate this. So 800 multiplied by 5.0757. So 4060.56. 4060.56 rupees. Now let's look at the fourth method, which is to use a financial calculator. Now the third method that we saw comes in very handy in practical use when we have to find out compound interest for multiple values of I, N, and A, especially for people who have to find out the present value of an annuity on a regular basis. The third method comes in very handy. The fourth method, which is to use the financial calculator, is also a very quick method. There are 5 main keys on the calculator that need to be used. First is N, which is the number of periods. In our case, it is 6. Next is I, which is the rate of interest. In our case is 5%. Now, while we are using the formulas, we generally take I as the rate of interest divided by 100. However, when we use the financial calculator, we have to use the rate of interest as is and not divided by 100. Next is the present value, which we have to find out. Next is payments. Now this payment is generally used in case of annuities. In our case, it is 800. It is positive because this is a inflow into our pocket. The next button is future value. Now in this example, the future value is basically the payments because those payments are being received in the future. So this future value we'll consider as 0. So let me pull my calculator. Now the method to use this financial calculator is to first key in a value and then let the calculator know what this value stands for. So N is 6, then 5 is I. PV we have to find out, so we'll click that button at the end. Payment is 800, so we'll first do 800 and then click on payments. Future value is 0, so 0 is the future value. And now we have to click the button that we want to find the value for, so present value. So we'll click this and the answer comes to 4060.55. So the present value is minus 4060.55 rupees. Now why is this minus? Because rupees cannot be negative. So negative indicates that this is an outflow because we are going to deposit this much amount into the bank so that we can get an annuity of 800 per year. So as we have seen, all the 4 methods gave us the same answer, pretty close. In one method I think it was 4060.56, but that's pretty close, and that's because of the rounding of the decimals and so on. So depending on the method that suits you the best, you can choose any of these methods.